So I am the innovation manager for this project located in France from Nokia. So I will first present the consortium. So the project coordinator is Emilio Calvanes from CEA, Leti. We have a technical manager who is Henk Wilmersch, and I am the innovation manager. We have 10 partners in the consortium from different countries. So in France, we have Orange, Nokia, CEA, and IMS. In Germany, we have Bosch and NEC, and Italy, we have TIM. In Sweden, we have Chalmers University and Radchat. So the project is focused on joint communication and sensing. So they were considered separately so far. So we are considering to integrate sensing and communication, because there is a mutual benefit by doing that. So first of all, sensing can assist communication. So sensing can help communication in the sense that it can estimate the channel or predict the channel. So it is beneficial for beam alignment, for example, in tracking, in risk configuration. And conversely, sensing can help communication, or communication can help sensing, in the sense that we, especially in a distributed architecture that we are considering, we have the communication network will help to transport the data between the different nodes. And the other benefit of integrating both is that we are using leveraging the common infrastructure, so we can leverage wide area mobile coverage to deploy sensing services. So going a little bit deeper, so as I said, the GCAS allows to reuse the hardware assets. So in other terms, the mobile infrastructure. We are reusing the same spectrum, and we expect minimal impacts on the 5G NR radio access. But nevertheless, control signaling and as well as the transmit signal and the way to share the measurements will slightly impact. So we are targeting 6G, so we still have time to consider some impacts, but we are trying to keep them minimum. But we have new protocols, new control signaling for all this. So another innovation of the project is reside in the usage of the semantic communication and goal-oriented communication framework, which goes very well with the targeted distributed architecture. So on the left, we can see the state of the art, so which is bistatic and monostatic architectures. On the right, this is what we are considering. So in distributed ISAC, we can have an arbitrary number of transmitters and receivers. Each can be a base station, G0B, or a UE. So and each category can play the role of transmitter and receiver. So there are multiple advantages of doing that. So we can observe the target from different angles. We can consider several targets. We expect to improve the classification performance. And we can implement super resolution distributed signal processing. So we are also adding a RIS in the scenario to complement the system. So RIS have multiple advantage in terms of synchronization, especially. So this is a DISAC architecture. So there are transmit and receive nodes. So we call and each of the receive node can have a local data processing. And we have a fusion center that will process the data from different receive nodes. So we consider AIML in the receive nodes, which could be a federated learning complemented with semantic framework. So the reason for having this local processing system is to reduce as well the load on the transport network. So the transport can be the backhaul or the radio network in case we are using UE as receivers. So we we expect to unlock the limitation of the conventional ISAC by the different methods. So I will not go through the list individually, but we have we are targeting a scalable architecture with resilient properties, thanks to the distributed ISAC, the combination of distributed architecture with AI/ML and semantic communications. So coming back to the semantic layer, so we have different domains. So the radio domain, which is the classical domain. On top of this, we have the semantic domains with a logical plane. So we are leveraging semantic and goal-oriented communication for distributed integrated communication and sensing. And the semantic channels support intelligent control on what should be transmitted. So this is an interesting property in the sense that the system will learn and optimize itself based on the history of the system. So it can, in other terms, learn a more parsimonious and efficient information representation in such a way that we do not consume too much on the network to transport the sensing data. We have also a set, of course, targets. So we have stringent targets. So this is based on 3PP state of the art for conventional KPIs, so the latency, energy efficiency, positioning accuracy, sensing performance, and spectral efficiency. So we are targeting order of magnitude improvement over these 5G performance. So you can see, for example, and that concern all the key KPIs of sensing. This is a more detailed view of the KPI that we are targeting. Of course, I will not go into all of them. And an important aspect also, I'm looking into the last line of classification accuracy. So thanks to distributed architecture, super resolution algorithms, and the fact that we can observe target from different perspectives, we expect very significant improvement on classification with respect to a monostatic or bistatic, for which we have just one view angle, and frequently with LCS, which is not precise information.
Philippe, you have 1 minute left.
Yes, it's I am on time. It's my last slide. So standardization is a key objective. So we need to take the solution developed in the project to the standardization bodies. So there is a pre-standard work started end of last year in ISG in HC. So which has a very good alignment with our objectives in DISAC in terms of scope and timeline. And it is a good preparation for the standardization in 3GPP. We are promoting this distributed architecture with us, which has a lot of advantages with respect to the conventional schemes. And we have, of course, several members of the project that are participants to the ISG, and we are targeting, of course, 3GPP. So for the moment, there is nothing started in 3GPP accepted in SA1 list of use cases and in Run 1 the channel modeling. And the consortium includes influent actors in 3GPP, so we are very confident that we can be impactful. And we're also considering other relevant bodies to promote the ideas and to socialize our concepts. Thank you very much for your attention.
Thank you very much, Philippe, for this nice overview what 6G-DISAC will be working on.